Hi, everyone. I think we are good to get started. I'll just introduce myself really quick. Feel free to say hi or something in the chat if you can hear me. It's a little hard when I can't see anyone, so I'll make sure that you can all hear me okay. I am Morgan Cundiff. My pronouns are she, her, and I'm going to be talking a little bit about machine learning and how it works and how it can kind of be similar to life and decision making in general. Thanks everyone saying hi in the chat. Oh, all right. All right, so I'm going to ask you all to, do a little participation exercise for me. So you can do this, in a notebook, in Google Drive, in your notes app, in a journal, whatever is easiest for you, or you like to write in. You can put this in the chat if you want, really whatever works. But I'm just going to ask you to write down, what does success mean to you? I think a lot of us, want to be successful. We want to be achieving. What does that mean to you? What does success look like? So I'll give you just, a couple seconds if you could write that down wherever you want to write it, in the chat, in a notebook, for yourself, for others, whatever works. I'll give you a couple seconds. Yeah. For a little inspiration, this could be, a job, it could be happiness, it could be really anything. So whatever you feel like writing down. Oh, great. Getting some answers. People are saying things. Yeah, you can type in the chat if you want, getting some questions in here. You don't have to, whatever works. All right, so feel free to, screenshot this question if you want to come back to it, but I'm gonna move right along. All right, so let's think about this for a little bit. In machine learning, we don't get to kind of qualitatively describe these things however we want. So what if we can only use easily defined concepts that we can actually measure, either, numerically or, with a word or text, something simple that is easy to measure. So let's try this same exercise one more time. But how do you know if you have achieved success? So how are you going to measure that, right? If you put something like, to be happy, how are you going to measure happiness? If you put something like, making a mark on the world, how are you going to measure that mark? Is it by like number of people who've said their lives are changed? How are you really going to measure that? And then how are you going to figure out if you're getting there, right? So what are the steps along the way that show that you're making progress and can help you keep track of how you're getting there? So again, I'm going to, give you a couple seconds. If you want to put that in the same journal, you want to put it in the chat again. I think there's, some different metrics depending on what you said success was. Of course, there's a bunch of different ways you could go about this. I'll give you 10 seconds, but feel free to keep answering this as we go along. I think it's kind of an important question in general, though it'll be relevant again later. All right, 3 more seconds. Great. Okay, so let's take a step back before we come back to this and talk about what this might look like in a machine learning model. So just, take a real step back and say, what even is a machine learning model? How does it work? So, most machine learning models, they learn based on examples, which is kind of the way we learn how to determine things. So if we use a really simple example here, say that we're trying to teach a model how to tell the difference between apples and bananas. All right, so we have some examples here, right? We have an apple, a banana, and then another apple. And we're going to give the machine learning model some information about that fruit, right? So here at the top, these different categories, we have the shape of the fruit, the color of the fruit, and the age of the fruit. And so these are different things that the model can use to try and determine what fruit this is. So here, this first one, we have that it's round, that's red, and then it's 3 days old. And so say the model guesses apple, and we're like, oh, very good job. You got that right. You said apple. It was an apple. And maybe it made that decision because it was 3 days old. It thought that the age was really important. So now that it's got it right, it thinks, okay, great. I can keep relying on the age. And then we see this next one here is long yellow, but it's also 3 days old. So it's going to guess the same thing. Another apple. And we're going to say, oh, that's wrong, right? It was a banana. You said apple. That's wrong. So the model is going to say, oh, I was paying attention to the age. So I thought that's how I was going to make this decision. I'm wrong. So now I realize that maybe I should be paying more attention to the shape and color. And so then this next one, we see round red again and a different age. We're going to again guess apple because now we're paying attention to the shape and color. And that's correct, right? That's what we want. This was an apple. It was round and red. Great, good job. And so now our machine learning model is learning what it needs to pay attention to in order to guess with new data. All right, so let's play a little game here. Let's pretend that we all are the machine learning model, and we're gonna have to tell the difference between these two made up species of thing, right? So we have the castaways versus the bobs, and all we get is a little bit of information about them. So we get its shape, its color, and its age, and we have to try and figure out how we're going to tell the difference in the future. All right, so if you all want to guess, here we have that the shape is a square, color is red, and age is 2 months. What do we think this is? We think it's castaways, the bobs. You can kind of guess randomly. You can guess your favorite. You can guess the first alphabetically, whatever you want, whichever you can. If one just calls out to you, go ahead and guess. Okay, great. I'm getting some guesses here. People are posting. All right, and so the answer to this one is this is a castaway. All right, so it looks like some people got it right. Some people guessed Bob. It's a little random because we don't know anything yet, right? We're just learning based on examples. So now we know castaway was the correct answer. So we can kind of we have a little more information. All right, so this next one is a triangle. It's yellow and it's 3 days old. So we can guess again, the same thing. Do we think it's a castaway? It's a bob. We have a different shape, different color, and different age. So it's a little bit hard, but let's take a guess. All right, getting some guesses here. This is also a bob. Or this is a bob, sorry, not also a bob. So now we have a little more information. We can't be quite sure yet which of these, categories are influencing the decision, but we got a little more information. All right, so now we have another square that's also red, but this one is 6 months old. So what do we think this one is? It's the same shape and color as the first one, so that gives us a little information, but it's a different age. It's a castaway. All right, so we got some people getting it, right? We've got a lot of people saying Bob still. Oh, a lot of people saying castaway. Good. All right, so we're getting a little more information. Okay, so now we have a square, which we have seen before, but the color is yellow. We've never seen a square that's yellow before, and this is only 3 weeks old. So what do we think? Do we think the shape is important, the color important, age is important? How are we going to make this decision? One more guess. All right, and it's a bob. All right, so we have a lot of information now. We can kind of decide, now we've seen a bunch of different combinations of shapes and colors. We can kind of pick what we think is most important. All right, so now we see a whole new one, a cube. We've never seen a cube before, but the color is yellow, and we have seen yellow before. And the age is 6 days, which we also haven't seen. This is our last one. What do we think? Do we have enough information? The color of this one is yellow, someone's asking. All right, this one is a castaway. So what do we think now that we've gotten this? How are we making this decision? Right, it seems like, oh wait. Did I label this wrong? Everyone's telling me I labeled it wrong. See, that's great. You all are paying attention and realizing that the yellow ones are the bobs. So it's even better, right? So you're learning just like a machine learning model would learn, right? Yes, in the chat. Yellow is bob. You all are right. So this is great. You caught an error in the data and you're saying that like yellow ones are bobs. We've learned from the previous data, the yellow are bobs. So great job, everyone. And I hope you're learning a little bit, like this is how a model learns the same exact way, right? It gets more and more examples and it steadily learns like, oh, I have to pay attention to this one. Oh, anything yellow is a bob. I've learned that the shape doesn't matter. So even though this is a new shape I've never seen before, I don't have to pay attention to that. And I know that it's yellow, so it must be a bob. All right, so if we go all the way back to the beginning, we were talking about what we define success as and how we're going to build metrics to really tell how someone is successful. So if we have a machine learning model, right, it's really hard for it to measure, is someone happy? Is someone making a difference on the world? It needs these like really specific examples where you can tell it these small metrics that are actually measurable that it can use to make the decision. So if we're trying to make a model that can predict if someone is successful or not, we have to decide what of these data points we're going to give it, like, right, which of those categories. So in the previous two, we were using shape, color, and age. And we found out that, age didn't really matter when we were deciding between the castaways and the bobs, and the shape didn't really matter. It was only color. So we have to decide kind of what metrics do we think are important to determine if a model is successful. So I kind of went through and I did this one a little bit custom. So I used to think that I really wanted to be a doctor. And I did, when I was in high school, I did all this research. How do you become a successful doctor? What does it mean to be a successful doctor? How do I write out goals around becoming a successful doctor, right? And there's a bunch of different things that go into that, but there's a couple that are easily measurable that I could write down as like things to accomplish to be a successful doctor, and that would show that I was becoming a successful doctor. So here's a couple of them, right? Getting into prestigious med school, right? That's kind of important to being a successful doctor, is going to a good med school. Wanting to do a residency in California. There are a lot of great hospitals in California. It's got great weather, great place to live, great place to be a doctor. So, maybe that was part of what I thought was becoming a successful doctor was, part of success was getting a residency in California and excelling at pre-med requirements, right? So if I wanted to do all these things when I went off to college, I had to do really well in my pre-med requirements and be getting good grades in those. And that way I could tell that, I was on my way to becoming successful, because to me that meant becoming a doctor. And I would be successful if I was able to do these things, right? So if we were trying to train a model using these metrics, we would go through and say like, okay, showed a bunch of examples. Did it go to a good med school? Did this person, get a residency in California? Did they excel at their pre-med requirements? And then we're going to label like, yes, no, they were successful doctors or not. So then we have some data, yes, good med school, yes, residency, yes, pre-med, yes, they were successful. And then the second person, yes, they went to a good med school, yes, they got a good residency, and no, they didn't do well in their pre-med requirements, right? Maybe this person, didn't do so well on their pre-med requirements, but, they had great extracurriculars. And then after undergrad, they went to do a bunch of, great project work with doctors, and then they were able to get into a good med school, and they still end up being a successful doctor. We have another example of people, yes, across the board. And then we have an example here of, yes, they got into a good med school. No, they didn't do a good residency. And no, they didn't do super well in their pre-med requirements. So maybe this person, didn't do super well in undergrad. They were able to get into good med school. They decided, this is not for me. I don't really want this. Or, we're struggling in med school for some reason, and then did not, continue into residency. Maybe they decided not to finish med school. They want to stop. And no, they're not a successful doctor. So the model is starting to learn like, okay, what do I have to pay attention to? Like the more yeses you have across the board, the more likely it is that you're successful, right? Because that's what we've taught it success means, is these three things, right? But, I decided when I was in undergrad that I didn't want to be a doctor anymore. I realized that like that was a great goal and that's what I thought I wanted, but there's this other thing like data science that is really exciting to me and really cool. So if I use the same model to predict if I was successful now, we have pretty much no's across the board, right? I did not excel at pre-med requirements. I didn't take them all, so definitely did not excel. I didn't get to a good med school because I didn't apply to med school, but also didn't get into a good one. And no, I didn't get a good residency. I didn't go to med school, so it's pretty hard to get a good residency program after that. So then based on this information, the model would predict, no, I'm not successful. And, I think that this is really interesting because it's a very extreme example, but it does show that the person who builds the model and chooses what data to send the model has a huge influence over what the model learns and who the model is going to define as successful, right? So in this case, this is a very narrow definition of success, right? So I'm encoding my own bias here that in order to be successful, you have to do things that really only doctors do, right? So according to this model, I'm definitely not successful, right? I did not complete any of these tasks. And, there might be those who agree with this definition of success and say like, yes, like in order to be successful, you should have become a doctor. You should have finished your pre-med requirements. You should have gone to a good med school. But it's also a very narrow definition of success, right? Like I would say that, I like my job now. I think I'm doing well, but I'm not a doctor. I didn't complete any of those things. So maybe this is a slightly extreme example, but I just wanted to show that whoever is defining these metrics, if they're doing it based on their own perspective, they can really encode their own bias and opinions about what these things mean into a machine learning model and how it learns. Right. And now we're not really measuring success anymore. We're just measuring, did I become a doctor or not? And that's not really what we wanted to be checking. We wanted to be checking, am I successful or not, whether or not I became a doctor. So we're not actually measuring the thing we want to be measuring anymore. All right, so I'm going to give another example that is maybe kind of relevant to all of you, but college admissions, right? So if a college is choosing whether to admit you or not, they have a bunch of different things that they can use in order to determine if someone is successful, right? Or if someone will be successful in college and they should admit them. And, this isn't always a model that does this. This is like often a human that is looking at these things, but it's kind of similar, right? They look at the extracurriculars the person had. They look at your essay or your personal statement. They look at the interview that you had with an alum or with a current staff. They look at your GPA. And, previously they looked at your SAT or ACT score. And then they're taking all these pieces of data in and trying to predict, should I accept this person? Is this person going to be successful at my school? And I wanted to bring up this example because I think it's really important, especially nowadays. We see a lot of schools that are no longer requiring things like the SAT and the ACT because we found that it was originally a metric that was supposed to tell, oh, is this person, able to learn this material? Are they able to excel at this material? And, are they going to be able to be successful in college? That's what it was supposed to predict. And it was a great intention, but after being used for a long time, people have kind of seen that, while, some people do well in the SAT because they, are good at the material and good at learning, it also can predict, were you able to do a bunch of SAT prep? Like, could you go to an SAT or ACT prep class? Like, did you have the time to do that? And the, access to classes like that. And a huge factor of how well you do on the SAT is also just your geographic location and where you live. So while, the intentions at the beginning were great and we did think it was measuring success, now that we have more data, we're able to look back and say, okay, this metric that we gave the model or gave the person is not really measuring what we thought it was measuring, right? It's not actually telling us how successful this person will be in college. So we need to reevaluate what we're giving this model or this person. And maybe we don't need to be giving that data anymore because it's not telling us what we want to know. All right, so this can also be kind of true in life and in life decisions. And I want to talk about that a little bit. Just like, we're giving this data to a human and those SAT scores, when we're making decisions in life, sometimes we have these ideas of what we think success is. And we have metrics that we're using to try and determine success. And sometimes we can get too stuck on those. So I want to give a little bit of a personal example in the last couple of minutes. This is really long, so you can read it later, but I'm just going to summarize really quick. So, I found some of my old goals when I was in college, and I really wanted to work at one of the, the top 5 prestigious kind of data science, software engineering companies. And I don't. I work at a very small company. And when I read this, I was kind of, stressing about it. I was like, no one has even heard of the company I work for. It's definitely not one of the top 5 popular companies. And I was a little stressed. But then when I was thinking about it and looking back and, thinking about, machine learning and these metrics we're using, I realized that, working at one of the top 5 companies is not the end goal. The end goal is to have a job that I enjoy and that I'm learning from and that allows me to live the life I want to. And if I already have that, I shouldn't be stressing over, the metric that I was using to get there. The point was to enjoy my job. So if I'm, stressing about this metric that I was using to get there and that's taking away from my enjoyment, I'm really hurting myself getting towards the goal. Yeah, so that is my little talk about machine learning. And I hope you learned a little bit about examples, how to tell the difference between castaways and bobs. This is my contact information on LinkedIn. If you have more questions about anything I've talked about, machine learning, my job, the company I work for, anything, please feel free to find me on LinkedIn and contact me. But yeah, so in summary, I just want to say that both, in our machine learning models and in our own lives, we do have to, look at the data we're using, look at the metrics we're using and say, is this really measuring what I think it's measuring? Is this really helping me achieve my goal? or not. So I hope you all enjoyed it, and I hope to talk to you again soon.